Hi, welcome to our last session of the day, Creating a Sustainable Factory of the Future. I'm Catherine Speglia-Nin, the managing editor at RCR Wireless News, and I'm pleased to welcome two Siemens execs, Sarah Blacksmith, who's the general manager, motion control, and head of factory operation, and Carl German, strategic lead of innovation in products and processes at Siemens Digital Industries. They're going to be discussing the company's strategies around digital transformation and innovation. So welcome and take it away.
Thank you very much. Yeah, it's great to be here. So Siemens Digital Industries, we wanted to kick off, just give you a bit of info about Siemens. So Siemens is split into a number of operating companies and some strategic companies, of which we are Digital Industries, and we fit within the operating company side of it. We've got an annual revenue of 87 billion euros globally, and a DI revenue of 16.1 billion euros, and we've got about 76,000 employees. We span across, process industries such as chemicals, water, wastewater, right the way through to the discrete manufacturing, such as automotive. So we are here today, though, to give you a bit of an insight into one of our manufacturing facilities, which is in Congleton in the United Kingdom, just south of Manchester. We are one of the oldest manufacturing facilities in the UK that has always been a Siemens site. We employ approximately 450 people, and we're manufacturing variable speed drives, which are, control the output of a motor. So all around, energy efficiency, which is really topical today, of which we manufacture in our facility approximately 1 million products annually. And that's a mixture of standard portfolio and configured portfolio that can be amended to what the customer wants, and sort of tweaked to be the best version for the customer. In terms of where we've come from, Carl and I want to give you a bit of an overview in terms of the journey that we've been on and the strategy, as Kat mentioned. So in terms of themes, if I go back to sort of 2018 and 2009, that's when the credit crunch hit, and it hit Congleton quite badly. We had a lot of stock, we didn't have any orders. We had to make some difficult choices at that time to get back to profitability. And then as a result of that, our strategy, going out to 2011 was all about becoming lean, becoming world class, and really sort of shoring up the way that we produce to sort of set us on that journey of continuous improvement. Moving on into our strategy for 2015, that was all about becoming world class, benchmarking ourselves against the best of the best, in the UK and globally. And we use the EFQM, the European Foundation for Quality Management, business model as a structure to work to. And so, that was all around safety, quality, cost and delivery, and really sort of getting our metrics in the right position, and making sure that we, set ourselves as a manufacturing facility as a great reputation. Moving on into 2020, it was all about getting closer to our customers. So we had quite flat growth up until 2015, 2014 time. And it was getting harder and harder in terms of delivering productivity if you have quite a flat order intake. And so 2020 was all about, right, how do we get closer to our customers to deliver a product and portfolio that actually is what they want? So that's where the configured product came in, that I mentioned in the intro. And so that was all about getting that product portfolio into the factory so that we could deliver that for the customer. And it was also how do we take a step change in productivity? So we've done a great job up until that point in terms of our lean journey, making small continuous improvement steps, but actually there was a whole lot of things that we weren't looking at. So from a digital enterprise point of view, using the different tools and techniques that would highlight productivity, enable us to get productivity into the factory quicker. And also things like advanced manufacturing, so robotics, 3D printing, automation in general, AGVs. So all these things that we weren't really, engaged with, and that's a real sort of step change in productivity for us. And so 2020 was all about that advanced manufacturing and digital enterprise piece from a productivity point of view. So before we get into that, though, which Carl's going to share with you, one of the key things of our strategy and of our, manufacturing facility in general is it is all about our people. Without bringing our people and developing our culture, we're not going to be able to deliver any of the good things for Siemens and for our customers. So we started on a journey in terms of where we wanted to be with our culture, called ownership culture. And this was all about, acting as if it is your own business. So really identifying, where is it we want to be in terms of the behaviors. So if you want to change a culture, you need to be really clear on where you want to move your culture to. And for each of the teams, like, what do we expect for people in terms of how they're behaving? So you can see this wheel here. It was all about around 8 different areas. So, being respectful to one another, motivating, engaging, being bold, decisive and courageous. So these were all things like where we got our employees together and said, right, what does that actually mean to you? And we came up with a common statement around all of that. That then enabled us to say, right, instead of just having discussions in our performance management process around, what people are achieving, we were actually then able to have how people were achieving those targets and have discussions around that. So it's all around giving continuous feedback, having continuous dialogue. And that was really an enabler for us to start having those discussions by being clear on what was expected. So yeah, from a people side, it was also taking people out of the day-to-day business and giving people time to think. So people in an operational role will know that it's very difficult when you're trying to deliver the daily requirements of the business to take that time to think, all right, okay, what does my strategy need to be? Where do I want to go in the future? What are the target conditions that I see as having as a business? And so it's for us in Siemens Congleton, Carl was one of those people that from a strategic side, right, what take that time, come out of an operational role, and really think about what is it that we need to do. So in terms of how did we digitize and automate our factory, I'm going to hand over to Carl, so he's going to share a case study of things that we've done in our factory. To you, Carl.
Okay, thank you, Sarah. So first of all, really, as with most, our industry is facing new challenges, disruptors, opportunities. Customers are becoming more consumerism-esque. They want choice. They want it now or yesterday even. There's new verticals, new segments that are emerging. Some are declining. So if we think about the car industry and the combustion engine, versus electric vehicles, there's certain technologies and processes that are declining and certain ones are emerging. And also, sort of global events, market disruptors, supply chain disruptions, organizational disruptions. Think about sort of cyber security and cyber threats. And if I was talking about our organization sort of 3 years ago, it'd be a different conversation that I was having 8 months ago, which is probably a slightly different conversation that I would have now, based on certain global events that have taken place. So this all calls for a business to operate at pace, be flexible, be efficient, be resilient, and 2 sort of core factors really that I'm trying to sort of convey in this slide really is, it's all about sort of innovation, but it's also about connectivity. And these are sort of two terms that are quite close to my heart. So if you want to forward on, Sarah.
Mm-hmm.
And really, what I've tried to do is a bit of a busy slide, and it's intentional, but it's kind of showing some of the innovations that we've done, but there's four sort of key categories really, in terms of skills, capabilities regarding innovation. I mean, one of the sort of key factors is that we've really looked at our sort of productivity, so our year-on-year improvements to the business overhead, which typically can run at sort of 5%, and actually can we achieve a sort of 50% increase in that productivity through embracing technology, through digitalization and innovation, and also it's not just about the factory, but how you take those particular opportunities and actually get them into at source, as in the actual design itself. So lots of technology, lots of innovation across our entire end-to-end that hopefully creates opportunities and makes us more profitable and provides that additional value to our customers. So if you want to forward on. So what does all this mean, to be honest? Well, what I want to do really is to quickly sort of show you a use case that we went through, which hopefully has a few sort of touch points through our sort of innovations and digitalization and automation technology that we've been deploying at Congleton. So the example I want to show you actually is a piece of automation. You can see the products on the left-hand side. You can see the actual eventual automation platform, and I'd call this a sort of a digital twin of that automation platform. And the main protagonist in the story is the cardboard box. And I've got a newfound respect for cardboard, to be honest. It's a tricky material to actually automate. So let the story begin. So Siemens coined a number of years ago these sort of 5 digitalization steps, and you can think it in the context of a product, so designing a product all the way through to selling it to the customer, and then having a service to that product, or you can actually think at it at a machine level, so an actual asset within your factory. So what I'm going to do now over the next few slides is give you some insights and into some of the sort of digital technologies that we've used to facilitate this step change within our factory. So the next one, so segue slide. So the first one really was sort of product development or sort of machine development. And what we did here was, the important thing about this particular project is it had many consortium members actually. So it had manufacturing engineers within Congleton, it had R&D engineers within Congleton, it had the supply of the packaging, it had the supply of the machine. So lots of interaction, lots of creative thinking to arrive at an end solution. And obviously what was really key here was that you've got that sort of efficiency of collaboration, and there's no better way to facilitate that than using sort of digital tools and digital modeling. So you can see here in the top left that we started off with a concept, a rough concept of the design. And then on the right hand side, in the top right, you can actually see where we're using our virtual reality computer aided virtual environment, our CAVE, to peer review this. So this is really important because it's a technology that's reusing the rich digital content, bringing people together and actually reviewing and actually understanding its capabilities in a virtual world. And this is really, really important. It's all about learning and failing in the virtual world. If you're learning and failing in the physical world, that's costing you time and money. We had to think about the packaging as well, because this was an automation project. We had to take the packaging that was designed for manual assembly and actually change it so it could be automated. So again, this was really important because it's about how do you facilitate that into the design process moving forward as well. And ultimately the solution was evolved into what you can see in the bottom left-hand side, which is I think a pretty good representative digital model of the actual solution. So in parallel with that process, we have what's called sort of production planning. So here using more sort of rich digitalization tools to simulate the factory. So, you know, our factory is represented in terms of resourcing assets, and what we've done is to model our factory so that we can actually understand the efficiency, the utilization, and the capacity of our factory. And in this instance, it's some case scenarios to do with different automation levels of this particular solution. And again, this is really important because, you know, you can scenario test in a safe place and not make, you know, changes to your physical production flow and find out that actually there's something not quite right. So, you know, sort of parallel simulation and production planning, whether it's in parallel with a concurrent, you know, design or of a product or a machine. And then you can see in the bottom left, actually, the sort of the evolution of our factory in the sort of digital context, and, you know, applying sort of simulation models and processes wherever we can. So again, as a further parallel process to that, on the next slide, Sarah, is the actual engineering of the processes. So here, what we've used is kinematic modeling of the actual solution. Again, what you can get from this is a real sense of the capabilities and the constraints and potential problems with the end solution in a virtual world. So then you can articulate that and you can make changes ultimately, so that when you commit to the physical world, you know, you're very confident that what you're actually going to implement is actually going to be fit for purpose. I mean, one of the next steps that we want to take with this is to take the, you know, the kinematics and actually, from a software point of view, use the model to download into the actual physical assets. So things like robot programming actually becomes a more efficient and effective process. And yeah, again, you know, we're all about using sort of novel technologies. So, you know, there's some complexity within this end solution. So, you know, we've used 3D additive manufacturing to create, you know, some you know, complex robotic end effectors. So again, it's all about, again, you know, learning and simulating in the virtual world, you know, reusing that rich digital information. You know, the actual product used in simulation is the 3D product that's been actually designed as part of the product development process. So again, highly efficient reuse of information. But obviously, then we're into a situation of, you know, we need to physically build our products. You know, an interesting point, you know, Sarah made, that we, you know, this make to stock strategy, moving to a make to order. Our, in terms of our part numbers within the factory in the make to stock world, we had roughly around about 700 to 800 part numbers across the whole factory in terms of our products. With the onset of one new product, which was a configured product, that went to 30,000. So suddenly there's an order of magnitude step change in the complexity of how you manage your products through your manufacturing processes, and how do you hit those really high efficiency points when you're doing, you know, when you're dealing with variation. Tuned into that, our manufacturing execution system, which is the software platform that essentially runs our factory, had been developed over 15 years and was circa 400 to 500 separate software components. So it worked, it was very good, but obviously that's not sustainable. So we chose to redeploy our manufacturing execution system to make it a highly connected ecosystem where customer orders would come in, and then there'd be rule-based systems that would take that customer order, use definitions from our production engineering department, use the definitions from our R&D department in our central repository, which is Teamcenter, and then pull in information to do with factory scheduling, and then actually create a recipe that would automatically be pushed down to the factory floor, that would then mobilize our assets automatically to manufacture exactly what we need to do, almost sort of heading towards that batch size of one. Now, whether it's the context of a piece of automation, or whether it's, you know, a sequential cell of manual assembly benches, the idea is that each bench articulates exactly what needs to be done for that particular product order on that particular assembly bench. And this was quite a step change for us. It's real time. There's no plan B. If the network slows down, production slows down. So part of our approach to this system was how can we be resilient? How do we make sure that the networks themselves are able to support the flow of the product without hindrance? So again, this is all about IT meets OT, so information technology meeting operational technology, and considering all the elements to do with connectivity, so cybersecurity, uptime of IT systems, network capacity, and all the other associated parameters that's required. But yeah, this is essentially our sort of future. And sort of some bonuses from this sort of architecture as well is that it's very scalable. So we can scale it, and the idea also is we roll it back into some of our legacy systems. So moving forward into the last arrow, which was about service. Data is the driving force behind everything now. I mean, data isn't new. Sometimes it's spun that it's this fantastic new novel thing that suddenly hit everybody. But data is as old as the industry itself. But the appreciation of data, the systems and the business systems and the intelligence and the processes we can apply to data has made a difference. And so really it's about how do we turn data into useful information. And we've viewed our core manufacturing processes in this instance in terms of core assets, core processes, and infrastructure. So it's about how do we use data to maximize the value of these particular domains within our factory. And part of that involves cloud-based systems. Some of these involve industrial edge based systems. So again, what we're now doing is understanding the role of high speed, low latency edge within our manufacturing processes, where you need to have very quick analytical feedback on the capability or processes or decision-making capability of those processes, but also how do you use cloud-based systems as kind of the overarching housekeeping element. So if we talk about AI, for example, deploying AI on the assets at the asset level using industrial edge and using the cloud to consolidate information to train your AI models and really make use of what I call that sort of data analytics vertical. And all this sort of feeds into that sort of wider sort of terminology of a digital twin. A digital twin is that it's a digital representation of your thing, your factory, your product that is actually using the physical information to make decisions or to allow it to sort of redefine or refine the performance of that digital model. So again, part of this is to sort of create that sort of physical world versus digital world closed loop ecosystem to really maximize the efficiency of what we do and the value to our customer ultimately. I think back over to yourself, Sarah.
Just gives you an overview, this presentation, this video of the what Carl's spoken about, the cell that we're talking about. That's the challenging cardboard that Carl was talking about. So thanks, Carl. I'll stop that. Move on to the next one. So what we wanted to do now is sort of say where are we going next. So our strategy at the moment is called 1 by 23, and it's all about well, for one, we've got a shorter time period because we recognise, to take what Carl was saying at the start, that things are moving a lot quicker now. So previously we would have gone over a 5-year range, and now it's much shortened, we feel. So probably 3 years isn't quick enough either, but this is our want to give you a quick overview in terms of the quick video, and then talk through what our plans are next.
Hit it! That's what I'm talking about. Wait! Okay, now, from the beginning.
So yeah, our purpose was in that video is all about doing what other people can't. We've got a great team in Congleton. We've got a number of different departments like R&D, customer services, manufacturing, all working together to solve problems for Siemens as a wider entity. And we're doing that so that people, as future generations will be able to work in Congleton as well. Our vision is that we are going to be undisputed number 1 in the market for variable speed drives, shaping the future with the brilliant people that we've got, the great ideas we have, and inspired customers that keep coming back to use our products. How our mission is that obviously every day, we care about each other, we support each other to be better than we were yesterday. We want to create an environment where people can think differently, they can have the time to think and do different things and work in different ways. And as Carl alluded to earlier, we want to be first to market. We need to be quick, and we need to deliver what the customers want next day, regardless of whether it's a standard product or a configured make to order product. So if I was to sort of give some takeaways to conclude, I think the first would be that it's, don't digitize waste. So before you jump on into a process of looking at looking at where you can digitize, as Carl's shown an example of, it's about making sure that that's built on a good foundation of lean, efficient processes. It's all about bringing the people with you would be the second one, giving people space to think, and giving them time to be able to make some mistakes and learn from those and act on and make changes based on what they've failed at. And the last point would be around, innovation leadership. Again, it goes back to the time to think. What is it? What are the problems that you're trying to solve? And how can you leverage technology, be it digital technology or automated advanced manufacturing technology to be able to solve the biggest problems that you have. So thank you for listening, and hopefully one day Carl and I can welcome you into Congleton in face-to-face. So thank you very much for your time.
Yeah, thank you.
So Carl, Sarah, thank you so much for that presentation. And actually, I thought maybe we could start with a question that both of you can address if you would like, but it's been a few years since you've began this journey. So are there any updates? Like, have you achieved what you were setting out to do? Or are you still in the process of getting there?
Yeah, I think I think we did achieve what we set out to do for the 2020 strategy. So the main part of it was about introducing a new portfolio and enabling that configured make to order portfolio. and making sure that we had the, like Carl said, the manufacturing execution system and all of the digital tools that enable the connection to the shop floor. So big tick on that one. That product is portfolio is now in place, and actually we've got a follow-on portfolio that's come through as a result of the success that we had on the first one. So from that side of things, yes, definitely. And the other side, from a productivity, we're running at 7.5% productivity at the moment. So that's definitely that 50% uplift that we've seen from the use of the digital tools, the automation technology that's been onboarded, in parallel with the continuous improvement still, which is absolutely key. Carl, would you add to that at all?
Yeah, I mean, one comment from my side is, there's a health warning of saying you've achieved your goal, because what we did, we created a North Star, but we appreciated that North Star is always almost out of reach. Yeah, because when you think you've hit the benchmark, somebody's gone and increased the baseline, or the target. So it's actually about continually iterating and improving. You think you've cracked it with the latest digital innovation, but there's actually something else on the horizon. So it's about saying, yes, celebrate the successes, but be mindful that competitive advantage, you have to seek it all the time, relentlessly, because everybody is trying to achieve the same goal.
Okay, great. And now going back to you, Sarah, I think it can be easy to focus entirely on the technology when we have these kinds of conversations. But as you made clear, it's really important to, particularly for Siemens, to bring its people and culture along with it as it transforms digitally. So what's at stake if a company doesn't do that? What are they risking if they kind of leave their workforce behind?
I mean, I think, if you don't bring people with you and they don't know why, there's not a compelling why as to, why you're going on this journey, then you're going to demotivate people. They're not going to be interested in making sure it's a success. So for me, it is all around making sure there's a clear why. What's your purpose? Why are you here as a company? How are you contributing to the world? And going on this journey, is it, you want to remain sustainable as a business? You want to make sure that you're, which is our why, we want to make sure that we're here for generations to come, that we're answering those big questions. We're remaining competitive in the global, the global market, and we make sure that there is a factory in Congleton, serving our variable speed drive customers for generations to come. So I think it's making sure you bring those people with you, because without them, you're not going to have a company anyway. So
yeah, exactly. And Carl, I think a big question for enterprises as they look to transform digitally and add more connectivity to their processes is kind of, what do I use for that connectivity? Do I use Wi-Fi, LTE, 5G, something else entirely? So can you talk to me a little bit about what connectivity you used here in this project and why you used it the way that you did, or where you used each technology?
Yeah, okay. So again, from a connectivity point of view, you can sort of almost, there's two camps. There's, your IT technology and there's your operational technology. And then you've got your sort of almost let's call it your consumer technology. So, your mobile, your LTE mobile phones, 4G, 5G. So from the sort of factory network perspective, obviously we've used wired networks. Those wired networks run the normal IT data information across the whole site, and from our controlling ERP systems down to the factory floor. And then you've also got connectivity systems within the industrial asset solutions, and the sort of protocols that exist within that connectivity can change. So typically the protocols between servers, computers, TCP/IP, standard stuff. But if you're running a robot with some form of supervisory safety, then you have to have protocols that are sympathetic to those requirements, which have been typically over wired networks, Ethernet, Profinet, for example. But obviously, we have a very flexible factory, and we do redeploy based on the requirements of the factory, and therefore, moving to Wi-Fi, industrial Wi-Fi, is sort of a natural progression to that. So it's almost like the mobile phone, 4G LTE. That's for mobile phones, and then moving to sort of industrial Wi-Fi for the interconnectivity of the assets that ultimately makes your factory flexible. I mean, clearly 5G is going to be interesting. It's potentially a game changer, because for me it almost links the consumerized mobile technology and brings it into the industrial context. So it's going to be really interesting to see how the evolution of Wi-Fi matches the evolution of 5G. And one of the questions are on similar paths in terms of speed, in terms of millimeter wave technology, which is very high speed. What's the value add of those associated technologies that they're bringing to the table that might be a differentiator for us? Does 5G unify the consumer side of mobile phone technology with the industrial side? It'll be interesting to know that if 5G was born through almost public telecommunications, how is that sort of facilitated into an industrial environment where you've got safety systems, you've got an uptime that's required, that needs definitive lines of responsibility of who owns what part of the technology. So I think mobile wireless technology is definitely it's what we're living and breathing now. I think what's really interesting is how Wi-Fi and the likes of 5G develop for the future, and what are the respective benefits and value added of those technologies.
Right. I mean, you're certainly right with Wi-Fi 6 and then 6E, and now 7 is not really that far away. Cellular and Wi-Fi really seem to be developing parallel to each other, and they're kind of neck and neck. It's very neck and neck. It's very interesting. So Sarah, what about reskilling? I know you just said, and you presented, that it's important to bring people along in this journey, but how do you make sure you are providing them the skills so that they can do that? And also, how are you inviting new skills in to support such a big transformation?
Yeah. So if I take the automation example, because that's the one that Carl touched on in the presentation, it's been a mixture. So we've onboarded, so in the first instance, if I start from the very first one that we implemented, we did it with a system integrator. So Carl led it with a team of engineers and stakeholders within the business with a system integrator. And that was the first step of starting to onboard some knowledge about how to execute an automation project. And then from there, we onboarded 2 experts around the robotics field over the next sort of year or so, and then moved existing engineers from other teams to create what we called a productivity through automation team. And then upskilled those people within the team through a mixture, and Carl will be able to add to this, of external training, also university training, and upskilling them using the experts that we'd onboarded into the company from I think it was Loughborough University was where they both went, actually, but they've been in industry as well. So in that example, it's been a combination of bringing people in, utilizing, upskilling those people from internal that joined the team, utilizing academic learning, and then also I guess industrial training courses, Carl, wasn't there, with the Cooker and with Universal Robots as two examples of brands that we've used in our factory. Do you want to add to that, Carl, around the automation training, or have I roughly covered it?
Yeah, I mean, everything what you said there, Sarah. Again, at the beginning of our journey, I mean, and I think this is quite important within the UK as well. You know, we've now got a good system of, you know, we talk about this sort of technology readiness level, and you know, research, developmental, experimental to, you know, off the shelf. And you know, there are now institutions, research technology organisations within the UK called catapult centres, and the idea is that they catapult, you know, research and ideas into industry, and you know, we use those as well to underpin and support our journey. And you know, if anyone ever says to me, you know, how do I go about this, you know, especially if I'm an SME, small to medium enterprises, actually, you know, use these resources to understand the capability, understand the context of automation, for example, in your business, and then, you know, understand what your supply model is for your solutions, whether it's you know, make or buy, and what makes sense.
And I imagine that security is a high priority for basically any company or enterprise at any given time, but especially when they are kind of changing things up. So, Carl, what were some of the biggest data and security considerations for Siemens as it kind of moved through this journey?
Yeah, so I mean, ultimately, there's a kind of a physical element and a cultural element. So, from a physical perspective, it's about how do you take, I mean, ultimately, you've got a potential threat outside the confines of your business, and you've got your resources that you want to try and keep safe inside your business. So it's about how do you make sure that the data systems and the connectivity systems can't be compromised. And again, depending on the nature of your connectivity and the scope of the connectivity, the rules of the games change. So it's about risk management, and it's managing risk in the context of your connectivity. So if you've got connectivity systems that stay within the confines of your physical organization, then there's certain approaches. If you've got you know, assets that maybe, you know, talking to the cloud, and the cloud is an external you know, connection, then obviously the rules change. So there's a huge effort in risk management of making prevention of data or access to our internal networks. But that also extends to the software systems we use. So you know, if we're using a third-party system, then you know, you're only as good as your weakest link. So if you're using third-party systems and software and products that have inherent security vulnerabilities in them, then you're no better off. So it's also about applying the same rules and principles to you know, tier 1, tier 2 suppliers, but obviously in a way that is you know, well, I'd say it's more than pragmatic, but obviously it's a risk management process. And then from a cultural point of view, it's the same. You know, it's making sure that people don't come to the organization with you know, memory sticks and you know, there's a lot of protection around, you know, the responsibility of individuals to ensure that you know, our business is safe. And we put a lot of effort into training, cybersecurity training, at both at a very technical, strategic level, but also at a very operational level, so everyone understands their role and responsibilities when it comes to cybersecurity, because it's such a topical and also a damaging you know, thing at the moment.
Thank you so much, Carl and Sarah. This has been really great for our viewers. Thank you as well, and please stay tuned for our chair's closing remarks.